In this video, you will learn about homogeneous differential equations and how to solve problems on homogeneous DE. A differential equation is said to be homogeneous or a homogeneous DE if every term of the equation has the same degree or exponent. So the exponent or degree can be on one variable or two variables and so on. A homogeneous DE can be written as m of xy dx plus n of xy dy equals 0. So this is read as m as a function of x and y dx, and n is a function of x and y dy. In solving homogeneous differential equation, there are certain conditions to follow. So we choose which one is simpler, which of the two functions m and n is simpler. So if m is simpler, then we use x equals vy. This is for if m is simpler. So what if n is simpler? If n is simpler, we use y equals vx, and we get the derivative of y again using product rule. So this is dy equals v dx plus x dv. Actually, you can use other substitutions, but take note that we're going to integrate later in the problem, so it's better to choose the simplest substitution. Now let's try solving some problems. Let's say we're given this problem xy dx minus x plus 2y squared dy equals 0. Now let's check first if this is a homogeneous differential equation. So we have xy here. The exponent of x is 1, the exponent of y is 1. Therefore, the degree of this function here, equation, is equal to 2. And this one, if we're going to raise each one to the power of 2, we can use FOIL here. We still get the same degree, which is 2. Therefore, this equation here is homogeneous differential equation. And then we can write this as m function and n function, m and n function. So our m function here is xy, while our n function is negative x plus 2y squared. Now the next step we do is we choose which of the two functions is simpler. Of course, the function m here is simpler. Now since m is simpler, then we use x equals vy. So we let x equals vy, where dx is just equal to v dy plus y dv. And then we substitute these values to the original or the given differential equation. So this would become, okay, xy dx, x here is vy times y, then dx is vy v dy plus y dv, minus our x is vy, this one, vy plus 2y squared dy equals 0. Then we simplify this. This would become vy squared times v dy plus y dv minus we expand vy plus 2y squared. This would become v squared y squared plus 4vy squared plus 4y squared dy equals 0. Alright, so let me delete this. And then we further simplify. Right. We distribute this one to here. So this would become, okay, this is vy squared times v dy. This would become v squared y squared dy plus vy cubed dv minus v squared y squared dy, because we distribute dy here, minus 4vy squared dy minus 4y squared dy equals 0. Right. And this one cancels out. So that is v squared y squared dy minus v squared y squared dy. And then we're left with vy cubed dv minus 4vy squared dy minus 4y squared dy equals 0. Now we can isolate the terms with dv and dy. So we can write the terms with dv on the right and the terms with dy on the left. So we have negative 4vy squared dy minus 4y squared dy equals, we transpose this to the right since this is positive, then transposing it to the right, it would become negative. So negative vy cubed dv. Right. And in this case, we can factor out 4y squared or negative 4y squared. So negative 4y squared, we're left with v plus 1 dy equals negative vy cubed dv. Then we can divide both sides by negative y cubed times v plus 1. So y cubed here cancels out the negative y cubed as well as v plus 1. Okay. Then we'll be left with negative, oh, the negative is already cancelled. So we'll be left with 4 over y dy equals v dv over v plus 1. All right. Okay, and now we can integrate this. Okay, so we can integrate both sides. We factor out 4, then we have integral of 1 over y dy or dy over y, then integral of v dv over v plus 1. So integral of 1 over y is just equal to ln of y. So this is 4 ln of y equals the integral of v dv over v plus 1. Actually, we can rewrite v over v plus 1 as v plus 1 minus 1 over v plus 1 dv. Since this one is just 1 minus 1 is 0, so that would be the same, equivalent to v. Okay, 4 ln y equals, okay, we can separate this integral as integral of v plus 1 over v plus 1 dv minus integral of dv over v plus 1. And this cancels out. This is dv. So we're left with, okay, let me delete this. So we have 4 ln y equals the integral of dv, because v plus 1 over v plus 1 equals 1, minus integral of dv over v plus 1. So we can let u here as v plus 1 and du is equal to dv. So it's the same as integral of du over u, which is just ln, so ln of u. So ln of u, integral of dv is just v minus ln of u, where u is v plus 1. So therefore this is ln of v plus 1 plus c. And now we can further solve this one. Since this is a natural logarithm, then we can further solve this using exponential function with base e. And take note that the two are inverse operations, since ln of e to the x is just equal to x, and e to the x, ln of x is equal to x. So that means if you have an expression with e, then you can use ln to undo it, and vice versa. So we have here an expression with natural logarithm, then we can use exponential function to undo this. All right, let's do that. We can write this as e to the 4 ln of y. Okay, hold on. Let's just write everything. I'll put everything on one side. So let's say we put all of the expressions to the left. This would become 4 ln y. We transpose v here and negative ln of v1. So this would become ln of v plus 1 minus v equals c. And then we use exponential function e to the 4 ln of y plus ln of v plus 1 minus v equals e to the c. Since e to the power of a constant is also a constant, therefore e to the power of c is just equal to c. Right, then we can write this as e to the 4 ln of y times e to the ln of v plus 1 times e to the power of negative v equals c. And remember that from the very beginning, we let x equals vy. Therefore, v here is just equal to x over y. V equals x over y. Then we can substitute the value of v to this expression here. Right. Okay, let's do that. So e to, this is ln of y. Right. Take note here that e to the 4 ln of y is just equal to e to the ln of y to the 4th times e to the ln of v plus 1 times e to the negative v equals c. Then this one is equal to y to the 4th times, and this one is equal to v plus 1. Or we can write it this way, times e to the negative v. We substitute the value of v, which is x over y. So this is e to the power of negative of x over y equals c. And then we further simplify this. We have y to the fourth times v plus 1. V is x over y plus 1 times e to the x over y equals c. Then this would be y to the fourth. X over y plus 1 is just x plus y over y times e to the negative x over y equals c. Y here cancels out, and we're left with y cubed. Then we have y cubed times x plus y times e to the negative x over y equals c. Therefore, our final answer would be e to the negative x over y times y cubed times x plus y equals c. So this is our solution to the given homogeneous differential equation. Now let's solve another problem.